So we always express everything in terms of sine and cosine, and we're going to go ahead and begin problem 10, part A, by picking the uglier side of the equation. The uglier side will tend to be the one with a fraction or a plus or a minus. So we begin by expressing tangent x as sine x over cosine of x, and cotangent is cosine x over sine x. These are what we call ratio identities. Now, let's kick it back to 4th grade. You had problems like this in 4th grade, where you had to add with a common denominator. These two fractions can't be added because they need a common denominator. So what we would do is the common denominator would be 6 in this case, and if I multiply this fraction by 3, and I multiply this fraction by 2, I would get that 6 that I'm looking for. And then 1 times 3 is 3. And 2 times 2 would be 4. Now I can express this fraction as a single denominator because they're common. We propose the same thing here. The common denominator is going to be cosine times sine. So if I multiply this fraction by sine, and if I multiply this one by cosine, now they both have the same denominator. However, instead of writing it as two separate fractions, I'm going to write it as a single fraction with a common denominator. The problem has a plus. I'm going to go ahead and put that plus right there. We have sine times sine. That's 2 sines. That's sine squared. Same thing here with cosine times cosine. That's cosine squared. Please don't forget, one of the most important things in this topic is a Pythagorean identity. So this entire numerator, sine squared plus cosine squared, is equal to 1. The denominator comes along for the ride. I'm going to go ahead and split this fraction into two separate fractions. Note that we have a 1 in the numerator. When I separate them, it's still multiplication. It's not addition or subtraction. The addition, by the way, the plus sign disappeared because by definition of the Pythagorean identity, sine squared plus cosine squared is equal to 1. What I'm separating here are two fractions based on this multiplication. Knowing your reciprocal identities, 1 over sine x, that is cosecant x, and 1 over cosine x is secant x. We can go ahead and switch these around because it's multiplication, and we will get secant x times cosecant x, which is what we were trying to prove to begin with. Part B, may I suggest that we do the right side. Since the right side has fractions and subtractions, it's the uglier one. So we're going to express everything in terms of sine and cosine. Secant is 1 over cosine, and cosecant is 1 over sine. We're going to go ahead and leave the red part of this alone and focus on the blue part for now. We need a common denominator. Let's go ahead and do that. The common denominator will be cosine times sine, so this cosine fraction is missing the sine term. And the second fraction, the sine fraction, is missing the cosine term. We can go ahead and the numerator is sine times 1, which is sine, minus 1 times cosine is cosine, and the denominator is sine cosine, but this is not squared, okay, because this is a common denominator. So it's sine times cosine, we express that once. I'm going to go ahead and replace this with our new equivalency. This is a division problem, so let's set up a division problem. I'm following procedure correctly. I'm simply writing out the division problem in this manner. I'm not flipping anything yet. I'm not switching anything yet. I'm not doing any reciprocating yet. I'm not skipping steps. I'm going to put this over a 1. I'm going to go ahead and keep the first fraction the same. I'm going to change the division to a multiplication. I'm going to flip or reciprocate the second fraction only. Now, it might help you to notice these with parentheses, because these are package deals. These are binomials, what we call them. So this binomial will go ahead and cancel out this binomial. That does leave me with sine times cosine over 1, which is sine times cosine.